This video is an additional piece of course content for week 1 of the course Quantitative Analysis, Applied Inferential Statistics. I want to accomplish 3 things today. First, I want to introduce you to the idea of packages, the tools that we use to extend R's functionality. Second, I want to introduce you to the idea of projects. This is a tool within RStudio that we can use to make our analyses more portable. Finally, 3, I want to introduce you to some basic functions for exploring data in R. So first up, let's talk about packages. Packages are designed to extend the functionality of what we call base R. These are the fundamental building blocks of the R computing language. Packages are compilations of functions. This is the code that makes these functions work, and sometimes they also include data. If you've had some exposure to programming before, particularly with statistical software, you'll have learned about commands, specific instructions we send to a computer to get a desired result. In R, we're not going to call these commands, we're going to call them functions. We can get packages from a variety of sources, but today I want to focus on one source, CRAN. CRAN is a peer-reviewed source for disseminating R packages. Most of the packages we'll use in this course can be obtained through CRAN servers. And a great example of this is the tidyverse package, which gives us many of the tools we'll need to manipulate data this semester. To download the tidyverse package, we'll use the install packages function. This is part of the utils package. The package name needs to be wrapped in double quotes, as you see here. Be aware that you need to install packages once per profile on a computer. What I mean by that is, for every login on every computer, you'll have to install your own set of packages. The function install packages only works for packages available via CRAN. When we get to installing packages from other sources, we'll use a different function to do that. One of the great things about R is that many packages are actively developed, meaning that they are subject to regular updates that improve how they work or add new tools. To update your packages, so that you have access to these changes, you can use the update packages function. There's no need to include any text in the parentheses, but you will need to type a lowercase y for each package you wish to update. Finally, to open a package, you'll use the library function. You have to do this every time you open a new session in RStudio. So let's take a look at RStudio's user interface. In the lower right-hand corner, you'll see a tab called Packages. This will list all the packages you currently have installed on your system. You can scroll up and down in the window to view these different packages. I want to show you the process for installing new packages. I'm going to use that install packages function and include tidyverse wrapped in double quotes. That means a double quote before the word tidyverse and a double quote after the word tidyverse. I'm typing this function into the console, one way we can use functions in R. Then, when I'm done, I'll hit the return key. R will list all of the dependencies that need to be installed. These are other packages that tidyverse relies on. Occasionally, we will have to give R the OK to compile some of the code for us. We'll type a lowercase y and hit return. This is a normal part of the package installation process. Once we do this, each package will be installed and you can watch the entire process unfold on the console. At the end here, you'll see what we have and is an error. There is an incompatibility between R and RStudio that we're being alerted to. When you install packages, be mindful of errors that you get, since you will need to address any errors before moving forward. If you get this error, you'll need to update your version of RStudio. I've included some notes in the week 1 jotter for how to do this. I've updated RStudio now and have opened a new session. I want to load the tidyverse package, and I'll type the library function into the console to do that. Notice that RStudio provides suggestions for functions based on what you start to type. Also notice that when you start to type a function inside the parentheses, you'll get a pop-up that shows you some of the basic options for using this function. When you begin typing the name of the package, RStudio will again suggest package names for you to select from. You can use the up and down keys to move around the list and hit return to select the package you wish to open. Then hit return to load the package. One way we can increase the reproducibility of our work is to conduct analyses within a self-contained directory that does not reference files outside of itself. RStudio calls this a project. Projects keep us organized and automatically set the working directory on our behalf. This means that R will automatically save all the necessary output to the project directory. So when we use projects, we're never dependent on specific file paths. This makes our work very portable. To create a new project, go to the File menu and select New Project. Typically, we'll select a new directory and then Empty Project. Give your project a name and select where you'd like that project saved. Then, click Create Project. Once the project is created, RStudio will open up a new session and you'll be taken right into that project. To reopen a project later, simply double-click on the project file and you'll be taken right back to where you left off. Finally, I want to give you two initial tools for exploring data. The first tool is the assignment operator. Operators are symbols we use as shorthand in programming. In this case, we direct data from one object and place it in a second object. Objects are like buckets that can contain a wide variety of different types of data. For example, we can take data from an object called MPG and assign it to a new object called AutoData. The MPG data come from the ggplot2 package, part of the tidyverse, and are what is known as a data frame. These are tabular data. Note that we do not want to use the equal sign to accomplish this task. While it may technically work, and you may see it in examples online, it's not considered stylistically appropriate. So let's see this in practice. I'll open up my Week 01 project from the prior section and load the tidyverse package. We'll use that library function. Once it loads, I'll direct R to take the data from MPG, which is visible to R because the ggplot2 package is loaded as part of the tidyverse, and assign those data to a new data frame called AutoData. And there we are. If we look in the upper right-hand corner of the window, we'll see an area called Environment, and the AutoData object, this data frame, is listed there. Any object you create will appear in the environment. If we want to get a sense of what is in our new data frame, we can use the structure function. This will list variable names, their type, such as numeric or character, and give some example of the type of values that each variable contains. The output also lists the total number of observations present in our data frame. We'll replicate this function using the AutoData data frame we just created. We'll type in the syntax for the structure function and add our data frame name. Note how it is now available for autocomplete. And there we go. We see all of the variables that the data frame contains.